Yeah, last type of probability that we look at in AP stats is what we call binomial probability. And in this scenario here, we suppose that 35% of Americans are considered obese. And the difference is that in binomial probability, we're always looking for a set number of people. So we're looking at 5 people and seeing the chance that at least 2 of them are obese, or it could be no more than 3 out of 8, or out of 10, or out of 40. So binomial is a little bit different than geometric, in which we're going until we get our first success and then we're stopping. All right, so with that in mind, let's go ahead and look at the first example here, and that is, what's the chance that exactly 2 out of 5? So there's really 2 issues here. How do you get 2 people out of 5 being obese in this case here? Well, there's different ways of doing it. It could be the first and the second, or it could be the first and the third, the first and the fourth, etc., etc. So first of all, you'd have to come up with all the different ways that this could actually happen here. And you can see here, this is just 2 out of 5. This isn't something complicated like 6 out of 17. But there's literally, when you're done doing this here and come up with all the possibilities here, there actually ends up being 10 ways that this can happen. And so you can imagine that, once again, if it was like 6 out of 17, it'd be very hard to figure out. So there's just a shortcut. And how it works is, it has to do with combinations and permutations, something you learned about in Algebra 2. So basically, to find this answer of 10, you do 5C2 on your calculator. So it's 5 people, and how many ways can you choose 2? The other thing that needs to be done is, let's say we're looking at just the first and the second, one of the 10 ways here. That would mean the first person is obese, the second person is obese, then the next 3 people are not obese. So what would happen is we'd multiply these all together, and we'd wind up with 0.35 squared times 0.65 to the third power. Well, what if it wasn't the first and second? What if it was the third and the fifth? So that would be, not obese would be the first person. The next person would not be obese. Third person's obese. Next person's not obese. And then finally, the last person is. So once again, if we were to multiply this together, well, you'd wind up with, well, 0.35 squared, and then times 0.65 to the third power. So you can see, no matter which way we do this here, we wind up with basically the same calculation. So the way to do this quickly is to take 5C2, which is the number of ways this can happen, and then multiply it by 0.35 squared times 0.65 to the third power. Now, when you do this, you'll get an answer of 0.336. And there's another way you can do this on your calculator, and it uses a function. It's in the same area on your calculator as normal CDF, but it's called binom, and it's called binom PDF. And it works like this. How many people? 5. The chance of success in this case would be 0.35, and we would want to know 2 people out of 5. And if you were to do this on your calculator, binom PDF, these 3 numbers, you would wind up with the exact same answer. Keep in mind, this is what we call calculator talk, which really is worth nothing on the AP exam. So that's what I would usually write if you did this, but this is the way you want to show it mathematically from a math point of view. So that's how you do exactly 2 people out of 5. So what if we were to change this up a little bit here? Instead of saying exactly, what if it was no more than 3 people out of 8? Well, no more than 3 means either 0 or 1 or 2 or 3. So literally you'd have to do it for 0 people. That's 8 people, and that's 0 out of 8. 0.35 to the 0 power, because nobody would be obese, and then 8 people, I'm sorry, no one would be obese, right, and everyone would not be obese. And you do that all the way through here. So that's 0 all the way through 3, and you'd wind up with an answer of not 0.486, excuse me there, but an answer of 0.706. So that would be your answer, which is great. Now there's another way you can do this, and you can also use like binom PDF, and it's called binom, and then it's called CDF instead of PDF. So it's cumulative instead of precisely. And it's very similar to binom PDF. We're looking at 8 people altogether this time, see how it's out of 8. Chance of being obese is 0.35, and we want to know up through 3. And if you do that, you actually get an answer also of 0.706. So herein lies the dilemma. This is calculator talk, so how do we show this mathematically? You do it like this. The probability that x is less than or equal to 3. This means 3 or fewer. Write out the answer, 0.706. And the only thing it's missing is defining x. Well, what does x stand for in this case? X stands for the number of obese people. So you'd write out number of obese people. And then the only thing you're missing is, well, how many people are you looking at in this case? Well, it's 8. So you'd say out of 8. So this is the way right here, how to show it mathematically And it's a shortcut way of doing the exact same thing up over here. Either way would be right. Anything I wrote in blue would be correct. This is the calculator talk way. Finally here, what if instead it was out of 10 people and we want to know at least 4? So once again, you could write it like this, 10 C4, and you'd say, well, 4 people would be obese, and then 6 people would not. And then you do this, you do plus or, and then dot, 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 all the way up to 10 people out of 10, 10C10, 10 people are obese, and then 0 people are not. And you can figure out each one of these individually and add them together. And by the way, the answer ends up being 0.486. So how would you do this mathematically instead of doing it this way using binomial CDF? Well, you'd say it like this. What's the probability that x is greater than or equal to 4? And in this case here, x is the number of obese people. And this time it would be out of 10 altogether here. Well, here's the problem. If you do binomial CDF, it will not do 4 or higher. Binomial CDF always does 0 or higher. So if we were talking about 4 through 10, we couldn't actually use binomial CDF to do that. However, the opposite of 4 or more is 3 or less. And together, these two probabilities will add up to be 100%. So if we want to know 4 or more, all we have to do is figure out 0 through 3 and then subtract from 100% or 1. So what you want to do in this case is do 1 minus the chance that x is less than or equal to 3. Then calculator talk-wise, what you would do is you would do 1 minus binomial CDF. And we would have, in this case, 10 people, 35% chance of being obese, and we want to know up through 3. So if you were to do this on your calculator, you would also wind up with the answer of 0.486. So whatever way you want to do it, the blue way or the green way here, it works. Just know that if you're going to do this with binomial CDF, you have to turn it around and do 1 minus 3 or fewer. Alrighty, so here is the final problem. What about mean and standard deviation? So when you're dealing with binomial probability, the formulas would be, the mean would be n times p, and the standard deviation would be the square root of npq. So in this case here, we're talking about 40 people, so n is 40, and the chance of being obese is 0.35, and the chance of not being obese would be 0.65. So it'd be a really simple calculation here. You take 40 people times 0.35, and when you do that, you would wind up with 14. So that would be the average that we would expect out of 40 being obese. Likewise, same easy kind of calculation here, 40 people times 0.35 times 0.65. Punch it into your calculator and you wind up with 3.017. So that's how you find the mean and the standard deviation of a set number of people here. That is that in terms of probability.